Good evening, children. Vectors and scalars, multiplication of vectors, fourth lesson. Now, we'll start from where we left yesterday. We were to discuss about the examples in physics for vector product. And of course, some numericals we need to do. So, some examples in physics. For whom?
Cross product.
Yes, for cross product. Right. See, the most famous example is the torque. Torque on a rigid body, a torque on a particle, doesn't matter. Torque on a rigid body will be more practical for us to understand. When you open and close the doors anytime, you're applying a torque. So, torque on a body, on a rigid body, we say rigid body is, it is the distance between any 2 points will remain constant. On a rigid body, or even a particle also, not small mass particle. Torque on a rigid body is the cross product of position vector R bar and force vector F bar. Here we try to give a little mathematical meaning only, because anyway we'll come back to this somewhere in rotational mechanics, which comes after a few months, not now. A rigid body is something hard body, like even if you throw it, the distance between 2 points will remain same. It doesn't change. Non-rigid one is, say, a spring you throw, the shape of the spring keeps changing as it moves. So we're talking of a rigid body like that, and that can be given some kind of a shape, something like that, and it is hinged here. What did I say? Hinge. You can turn around that. Say you applied a force here at some point. This is a force. And this is the position vector. That is the origin through which some axis passes to the point where you apply the force. This is the point of application of force. So that is what we call as the position vector. This is a force vector. So the turning effect of this body, you know very well. Once it is hinged here, when I applied a force like this, it doesn't come off the hinge like that. It actually turns like that. Because supposing this angle is theta between R and F, this component will be mod F cos theta. This component is mod F sin theta. So mod F pulls it like that, but the hinge is not allowing it to move forward. But this part will turn the rigid body around this axis which is passing through the hinge. So it will rotate like that. So that rotating effect is characterized by a term called torque. That is tau, we can call it T in Greek. Tau equals this mod r into F perpendicular. This is F parallel. This F perpendicular to R. That will be mod R mod F sine theta. Or in short form, tau bar equals R bar cross F bar. So this is the first and foremost and famous popular example for cross product. Like force causes acceleration, linear acceleration, torque causes angular acceleration in a body, the physics part of it. But right now, you do not have to bother. You can give it a logical meaning only. Anything rotating may be having a torque acting on it. Rotating, of course, not with a constant angular speed, but with increasing or decreasing angular speed, that kind of a body will have a torque acting on it. But when you think it in terms of vectors, it is simply the cross product of two vectors, r vector and f vector. So in this lesson, if there's a question which is going to be asked, you'll be given torque and force vectors, probably in IGK form, and you will be asked to find out the torque acting on the rigid body. So you need to develop the technique of finding out the torque more than right now physically trying to decipher it, which may not be possible now. Okay, so this is the first example I'm giving you. All right. If you finish it, I'll continue, children. TORQUE. Yes, Ganesh.
Done, sir.
Somebody was saying, sir.
Yes, sir. It's what that was.
Now, say the force vector might have been given as, to illustrate that meaning of it, force vector may be given as some 2i plus 4j. Maybe this is x-axis, this is y-axis, for example. And r vector may be given as, depending on the angle it makes with x-axis, whatever, that may be some I bar plus 3j bar. Now, what is a torque? If somebody asked you, you'll simply say it is R cross F. When two terms only are given, it is easy to find out the torque even without going for the determinant I told you yesterday, because the multiplication is not so difficult. But if you'd like to write the determinant also, have no problem. Like I, J, K, you write. Now 2, 4, 0, because no K component. 1, 3, 0. So expand this tau vector, you get I into this, you remove 4 into 0 minus 3 into 0, right? Minus j into this goes 2 into 0 into 1 minus 0, 0 plus k into this goes. So 2 into 3, 6 minus 4. So ultimately, what did I get? 2k, which you can get directly here if you want. I cross I, tau equals R cross F. From here you should go. I cross I will be 0. I cross J will be K, isn't it? Plus 4k. Then with this 3j cross I. J cross I is minus 6k. J cross k is 0. So what do I get? Minus 2k. Oh, something went wrong here. Let me see. I cross I 0, I cross j, k. Sorry, from here you should go R cross F. 1 into 2, I cross I 0, I cross 4j, 4k, 3j cross I, j cross I, minus k only, no? J cross A 0, 3 into 2, 6, minus 6k. Something went wrong here, you check it. This is 2 into 3, 6, minus 4, 2k. Here, R cross F, I cross I 0, I cross j, 4k, right? J cross I, j cross I minus k only, no? 3 into 2, minus 6k. So minus 2k I'm getting. What happened here? Did I write properly everything? Here R I should have written first, no? Sorry. This should have been here, this should have been here. R component here, this one here. So you'll get minus 2k here also. Check it. Did you understand? Hello?
Sir, once can you explain determinations?
Yesterday I told you already. Look, when you wanted R cross F, R components must be there first, not F components.
Yes, sir.
1, 3, 0. Then F components 2, 4, 0. Expand this. I you should write first and remove this and this. You are left with this. Okay.
Yes, sir. Yes, sir.
So 1 into 4.
4.
4 minus 6. This you should remove, not that. You're not saying anything. Look, you should ignore the column, the row in which I is existing. So I into 3 into 0 minus 4 into 0, 0 minus j into this one you eliminate, you're left with this one. 1 into 0 minus 2 into 0, 0 plus k into this one you ignore, you're left with this. So 1 into 4, 4 minus 6. All right. So minus 2k. You should eliminate the row and the column in which that particular I or j is existing, and with the remaining thing, start from left and go to the right. Start from here and go to that and put a minus sign. Like this, you should multiply. You understand? If I'm writing for k, this column will go, this row will go. You are left with this. So 1 into 4 minus 3 into 6. You follow that?
Yes, sir.
Hello?
Yes, sir.
But it is even directly easy. I cross I 0, I cross jk, I cross jk, j cross j0, like that. It is easy to do like that. So to that extent, we require to know what is torque. But torque will be about a particular origin. So that you should mention, and we need to always find out this R bar from that origin. So that is the trick of calculating torque. If you finish it, I'll give one more example.
Sir.
So can I go to the next one?
Yes, sir.
On torque only, I'll give another example. A force F equals I minus 2J plus 3K is acting at a point 1 comma 4 comma minus 1, whatever it is, doesn't matter. Find the torque about the origin. So it will be like that, children. This is the point 1 comma 4 comma minus 1. Don't be here, try to understand. I just put randomly like that. You know where is 1 comma 4 comma minus 1? Huh? Just write R. R will be what? 1I plus 4J minus 1K. And F is already there. What? I minus 2J plus 3K. So tau equals R cross F equals what? I, J, K. R should be written first. R components 1, 4, minus 1. Then F components 1, minus 2, plus 3. Expand this. You know what? How to expand? I you take first. Ignore the column and row in which I is existing. And you are left with a small matrix like this. This way you go. 4 into 3, 12. Minus plus, this is plus 2, right? Minus 2 into minus 1. Huh? Hello? I put a minus here. J, ignore the column and row in which J is existing. You're left with 1, 3, and 1 minus 1. 1 into 3, 3. Minus 1 into minus 1. Plus 1, right? Plus K into, ignore this. 1 into minus 2, minus 2, minus 1 into 4. So what am I left with? 10I cap, minus 4J cap, minus 6 K cap will be the torque.
Sir, that should be minus 1.
Let me see. Where is it? This and this gone. I into 4 into 3, 12 minus plus 2. That's correct. Minus J into 1 into 3 minus 1 plus 1. K is gone. 1 into minus 2 minus 2. 1 into 4 minus 4. Where is the trouble?
So like when you multiplied 1 and 1, it should be minus 1 also.
There's a minus 1 and 1. Which component you tell me, Takshi? This one, this one, this one.
In J component, when you put
This went
plus
away,
1.
this went away. So 1
Yes,
into
sir.
3. 3 minus 1. Minus 1 is what? Plus.
Okay, sir.
Huh?
Yes, sir, I get it, sir.
Your mic has muted, sir.
Tell me, do you follow this? You remove the column and the row in which I exists. So 4 into 3 this way. This way, you need to multiply and put a minus sign in the middle. Do you follow? 4 into 3, 12. Minus 2 into minus 1, plus 2. Put a negative sign for the second one. Ignore this and this. You are left with 1 into 3 minus minus 1. Plus k into, this is gone, 1 into minus 2, minus 1 into 4, minus 4. Do you follow, everybody? Hello?
Yes, sir.
So if you finish it, I'll go to the next one. Next question. Hello, children.
1 minute, sir.
Sir, I and if we go to I to k it is positive or k to I it is positive when we multiply both I component x component, which is positive.
Now when I write this, it takes care of everything. But if you want to know I, j, k, you write I to j plus k, j to k plus I, k to I plus j. Come in the opposite direction, minus.
Yes, I got it.
Children.
Done, sir.
Now we'll come back to those examples again, but second example I'll give. Torque is one new physical quantity you understood. Then angular momentum. Whatever it is, just don't worry too much about it as a physics of it, as to the physics of it. But once again, let us look at it in the mathematical way. Angular momentum of a rigid body or a particle, doesn't matter. Particle is small point mass. About some origin O, like a torque, like the torque only previously, about some origin O is given by L about O. L, you give a name L to that. R cross P. P is linear momentum. Or R cross MV. Or mod L equals mod R mod MV sine theta. Here's one more example. So once again, it reduces to what? If there is an origin like this, you will find out this R. Then the particle velocity of the particle is mv, for example. Of course, for rigid body, you don't get mv, just remove this particle you write. For rigid body, you do slightly different. So this is the velocity of the particle, mass of the particle is m, for example. Mv is the linear momentum. So R cross mv is what we call the angular momentum of the particle about this origin O. Okay. So once again, knowing the vectors, you should be able to calculate. You should be able to calculate the angular momentum. And later in future, you will know that rate of change of angular momentum only will be the torque vector. So focus on how to find out the cross product, children, nothing else. Then another question, linear velocity. of a particle going around in a circle, not even circle, but in general also, but to make it easy for I'm writing like around a circular path is V equals omega cross R. Omega is angular velocity vector. R is once again the position vector. Just write down that. More of that will come back later. Because anyway, I showed you how to calculate the cross product. So every time you need to look for these vectors and just do that. The physics of it will come slowly. And another example I'll give you here. Force acting on a charged particle. Force acting on a charged particle Q of charge Q moving with a velocity V in a magnetic field B, magnetic field of strength B is given by F equals QV cross B. Q is a number, but this multiplied by the cross product of velocity vector and magnetic field vector. I'll stop here because there are more examples, but finally, my focus is to give you these formulas and somewhere use them and ask you to calculate these required quantities. Even if you did not know the physical meaning of it, there's nothing to worry about now, because we are developing one what you call technique at a time. Like once you know the logical mathematical part of it, later of course we'll take care of the physics part of it. Okay. So 4 examples I've given. Now I'll go for some simple numerical practice, after which we can go for a bigger assignment.
Sir, can you read the 4th example?
Force acting on a charged particle CLE Q moving with a velocity V in a magnetic field B is given by F equals Q V cross B. The cross product of velocity vector and magnetic field vector multiplied by a scalar Q. So if you're finished with that, let me finish off my numericals related to the cross product and even some of the dot product things.
Done, sir.
Right.
Wait.
Now we'll keep, yes. Suraj, what did you say?
Wait a minute, sir. Then
Right. Now, some exercise. Directly, I'll give a question. Find A cross B if A equals 5I cap plus 2J cap minus K cap and B equals 3I cap minus 6J cap plus 2K cap. Just that's all. So how shall we write? I, J, K. Then A cross B as so A components should come first. 5, 2, minus 1. 3, minus 6, 2. Is it okay for everybody? Then tell me.
Two into
Huh?
2 into 2 minus 6, sir. Minus 6.
Right?
Yes, sir. Minus
Minus J into
K 10 minus 10 plus 3, sir.
10 minus minus 3.
10 plus 3. Minus K.
Plus K. Plus minus plus gone.
minus 30 minus 6.
Minus 30 minus
6.
that's all. So this is what? Minus 2I minus 13J minus 36. And if somebody asked you the mod of it, if you wanted, what will you do? Minus 2 square, plus 13 square, plus 36 square, under
Root over. Yes, sir.
whatever it is. Okay? Tell me, children.
Yes, sir.
Do it fast. I want to give you more questions because then I can push you one big assignment. See, there are two things. One is your board exam. In the board exam, they'll ask you some derivations, whatever. The classwork, whatever you did. In the notes, it is there. Later, you can look into the textbooks, either CBSE or intermediate, whatever, and see what kind of questions are asked. You need to only remember, or even if you blindly practice also, that will manage. But the next thing, most important thing is all the assignments I'm giving, you need to solve. One general heading is for that, problem solving. So that is the one you need to really get into. Right. Can I go to the next question?
1 minute, sir.
Yes, sir.
Moshagya and others, tell me, this time, by this time I've done 3, 4 like that, right?
Then
Now, second, find the area of a parallelogram. I'll write like this every time. GM. Parallelogram with A equals I minus 2J plus 4K and B equals 2I plus 2J minus 3K. Find the area of parallelogram with A and B as its adjacent sides. Adjacent sides. Right? So what was the idea? Area of the parallelogram equals what? Tell me. Mod of
Mod of X.
So take A cross B equals, what will you write? I, J, K, tell me. 1, minus 2, 4, 2, 2, minus 3. You'll get A cross B. Then mod of A cross B you calculate. Come on. I will give it for you. Children,
minus 2i minus 11j plus 6k.
tell me, Sohita, once again. Minus
2i
2I
minus 11j
Hmm.
plus 6k.
Do you all others agree?
Yes,
So
sir.
mod of A cross B will be 4 plus 121 plus 36 under root. Okay. Hello.
Yes, sir.
How much is that? 125 plus 36. How much? 125 plus 36. 161.
Yes, sir.
So this many units. All right. Or if somebody asks you if a triangle, you will say half of it. So half of A cross B will be area of the triangle formed by these two vectors. That will be root of 161 by 2. Okay.
Sir, I think it's supposed to be plus 11j cap, right? Because inside the brackets it's minus 11 and
I don't know. Of course, let us see. This one went away. Huh?
minus,
So
minus
1 into
8.
3 minus 3 minus 8.
And then there's a minus on the outside.
And there's a minus sign outside. So it will be plus. Correct. Hello.
Yes.
Sahita.
Yes, sir.
Right.
Yes, sir.
Okay. So can I go to the next question?
Yes,
If you keep doing along with me, that won't take time, children.
Hence.
Done? Right. If mod of A cross B is equal to A bar dot B bar, find the angle between A and B. Very simple,
90.
right? Huh? Look. Mod of A cross B is what? AB sine theta is equal to AB cos theta, right? Hello.
Yes, sir.
Mod A mod B sine theta is mod A mod B cos theta. So what do I get?
$45.
45.
Right? See if it is 90, look. Mod of A cross B will be mod AB. mod A, mod B, but mod of A dot B will be 0. So they're not equal, assist. Huh?
Yes, sir. Yeah, that was the mention.
Next. If A equals I plus J plus 2K and B equals minus 2I plus 2J minus 3K, find the component of what? B perpendicular to A. You have the you are given already about that. Look into your notes and tell me. We're going to speak, children.
Sir, it's 0. Sir, null vector, sir.
We don't know. We'll see. How to do that? Tell me.
Sir, in that case, then B is perpendicular to A, then sin theta, sin 90 equal to 0, na, sir.
Look, mod of A cross B will be mod A mod B sin theta. Look, this is A, this is B. So we wanted the component of B perpendicular to A. That means we wanted B sin theta. Amar. So what will be B sin theta here? Tell me. A cross B mod by
Mod A.
mod A. Did you
Okay,
do this? Did you do this? Some 90 you are saying some 0. That's not correct. Huh? So mathematics must be perfect. So now A cross B mod you calculate. For that you know what to do, don't you? Huh? So
okay, sir. Okay, sir.
come on.
minus 7i minus j plus 4k.
Right? So that divided by mod of it calculate. 49 plus 1 plus 16 under root. This is the mod of A cross B divided by mod A. Mod A is 1 square plus 1 square plus 2 square. Huh? Under root. So how much is this? 66 by 6. Is this correct? Check the calculations if they are wrong anywhere. Huh? This is equal to what? Mod B sine theta. Hello? Do you follow?
Yes, sir.
Follow, I'll go to another one.
Then sir.
Now, given A equals I minus 2j plus 4k, B equals 3i minus 4j plus 6k. Find the unit vector perpendicular to both A and B. What do you do with this? You write this one. A cross B will be equal to mod A mod B sine theta into n cap. So he's asking you n cap. That is very simple. Vector A by mod A, nothing to bother. By mod A mod B sine theta, which is nothing but A cross B by, tell me, mod of A cross B. Do you follow? Any vector equals unit vector is vector A by mod A. That only. So A cross B is the cross product, any vector by its magnitude. That will be a vector perpendicular to both A and B. Right? Hello. So you need
Yes,
to
sir.
calculate. You need to calculate A cross B again. So every question is reducing to that only, right? Huh?
Yes.
So you should be now fast. You need to get this and divide by the magnitude of that. Do that.
Four I plus 6j
4i
plus 2k
4i
plus 6j plus 2k.
Is this right, everybody? If that's
Yes,
right,
sir.
then n cap equals 4i plus 6j plus 2k divided by 4 square plus 6 square plus 2 square under root. Okay? That will be the unit vector which is perpendicular to both A and B. We already have shown it previously. If this is A, if this is B, we have a n cap like this I told. That n cap we calculate.
Sir, like that n cap is not perpendicular to the A na, sir. It is only perpendicular to the B.
For both. The plane, if it is perpendicular to both. This one and that one. Vishnu.
Like I didn't understand, sir.
You're looking in the same plane, then how will you know?
It is in under, yeah, okay, sir. It is in the under, it is in the Z axis.
This is A, this is B, this is n cap. Right?
Yeah, okay, sir. Got it. It is 3-dimensional one.
All right, children. So there are various types being covered. You need to be very watchful, like, oh, this is slightly different from the previous one. So when you look at a question later, so you should be able to recognize it. Huh?
Yes.
I'm looking for your assignment.
Then, sir.
Done.
Then, sir.
Just a minute, I'm looking for one assignment. I found it. I'll send it. It's not many, it's 30 only. Yeah, 30, and I'll send you first anyway. Right, one more.
Sir, yesterday you gave one. SLE.
10, yeah. That, another 30, another 150, like that. Things keep coming. Okay. Let me do a little more of the cross and dot products. Simple question I'll ask. Huh?
Sir, it is A into B.
No. Let me see.
Sir, will you be giving us actual numericals, or is this like...
Whatever you want to tell. Look, this is A, Suhita. Huh?
Yes.
This is B. So A cross B is which way? This way, right? Vishnu, this is perpendicular to this whole plane.
Yes, sir.
Huh? You got, call it C, for example, if you want. So I'm asking you A dot C. So mod A, mod C, cos 90. Vishnuvardhan, tell me.
Understood, sir.
So that's what I was asking. Okay. Anyway, now it is your time. The 10
Sir,
and also.
like, can we distribute it to A cross B, sir? Like,
Tell me.
can we distribute dot A cross B to? Can we distribute, like, can we write it as
You
A
can't
dot?
write.
Sir?
No.
Yes, sir.
I'll tell you a few other things later. But right now, did you follow this?
Yes, sir.
Yes, sir.
Okay. All right. Try this 10 and also another assignment I'll send you because there is Sunday coming in the middle. Tomorrow also I have a class for you. Okay. So we'll discuss few questions tomorrow and later you will ask doubts. From the 10 I sent also, you can ask doubts first. Make it a habit to ask doubts, then doing everything one after the other. That will be a bad habit I'll develop in you if I keep doing every question.
Sir?
I can only give the key. Huh?
Sir? In the yesterday's assignment, I did not understand one of the questions.
We'll see. Anyway, I'll give you time tomorrow. I'm sending another one. All right.
Okay, sir. Okay.
Yeah. I'll close it now.
Thank you, sir.
Will you send it today, sir, the assignment?
Today only I'll send.
Yes, sir.
Thank you, sir.
Thank you,
Bye,
sir.
Chikar. Thank you.
Sir.